Hi friends, so today we are going to learn about binary search tree. So before learning about the binary search tree, let's understand what a binary tree is. So any tree like binary means 0 and 1. So whenever there are two maximum children of a parent in a tree, that kind of tree is called as binary tree. So I have one node, and then if I have two under it, and then let's say if I have one here, and then that's it. So is this a binary tree? For example, I have something like this. So is this a binary tree? Yes. Reason is, so first this guy has two children, this is two children, this guy has one children, and this guy has zero children. So that's how any tree which has maximum two children, under its node, like the parent has two, that's a valid binary tree. So do not confuse it with binary search tree and binary tree. So now what's binary search tree? So binary search tree is a special type of binary tree which is used to get the faster retrieval of the elements. So how that works? For example, now this binary tree doesn't have any constraint. Whatever element comes, you can put anywhere. Basically, the thing is you would put it at the deepest node. So let's say if this is 80, then you get 1000. So you can put 1000 here. You can put 90, whatever. But in binary tree, we have a restriction. So how it happens is this is a special binary tree in search. For example, first element is 80. So whatever element is lesser than 80 would go to left, and whatever is greater would go to right. So let's see this. If you have 65, it would come here because it's lesser. For example, if you have 90, would you like to put here? No, you would go 90 with that. For example, now you have 100. So can you like add it here or here? No, you have to first go, whatever is greater would go here, and then after 90, you have two options, like either it could go left or right. Binary means two, right? So where should it go? Since it's greater than this number, it has to go on the right. For example, if you have 95, then 95 would go where? So this is 90, and then this is 100. So any number lesser would come here, but any number greater is supposed to go on that side. So 95 is less than 100 actually. So it would come here, and then it would go here. So this is 80, 90, and 95. So this is 100. Then 100, is it less than 100? Yes, 95. So 95 will come here. Okay. So now let's take a use case of quick searching and let me explain you how this thing works in a logarithmic fashion. So I'm just putting 50, and then I'm putting 75 here, and I'm putting one more number, for example, 85 here. So imagine that this, if you will represent as the array thing, then how would it work? You have 80, 65, 90, 50, blah blah blah. So it would be, since you have to check each element, so you have to iterate like n times in the array from index 0 to n. But in this case, since you know the rule that, so it will give you the logarithmic search time, which means each time it would cut your search in half. So here, if there are 100 elements, you would iterate and check if your value matches that value. But here you don't have to do that. For example, you are looking for 50. So you come here, you won't even touch or go to these nodes. You would come here, then you would just say, hey, 50 is lesser than 80. So jump here. 65, it's lesser than 65. 50, 50, you got it. Your search is done in 3 steps. So that way it makes super easy when you're trying to search. And because search becomes the logarithmic, like each time it is cutting itself in half, because there are two branches and you're only going one side based on if based on the current node. If that number is greater or lesser, you would traverse it that way. So I hope you're clear with the binary search tree. Go to my GitHub repository and other videos where I'm walking through the code and explaining the different operations like the search, and then how to create a binary tree and binary search tree, and then how to iterate over the element and stuff like that, and traversing. So thanks for watching and subscribe to my YouTube video channel.